Welcome students. It is a good opportunity that you have to see here in this wonderful day. In this particular class, we are going to solve the given linear programming problem by graphical method. So this is a linear programming problem. By graphical method we can solve it. We can do by the another method called simplex method. We will see that later. Since this equation consists of only two variables x1 and x2, it is possible to solve this linear programming problem by graphical method. Objective function is maximum z equals 2x1 plus 3x2. Subject x1 plus x2 is less than or equal to 1, 3x1 plus x2 less than or equal to 4. Where x1, x2 is greater than or equal to 0. This is what LPP given to us. Right. Now what I am doing there, I am going to draw a straight line for this first constraints and for the second constraints. Now to draw a single line, at least 2 points are needed. 2 points are needed. Let us find the first point for this particular constraints. If x1 is equal to 0, I put x1 is equal to 0, x2 would be equal to 1. So if you put x1 is equal to 0, x2 is equal to 1, x2 equals 1, that I write here. This first point we have got. If x2 equals 0, x1 equals 1. So if x2 equals 0, x2 equals 0, what is x1 is equal to 1? That is x1 is equal to 1. So 2 points we have got. We have to draw a straight line for this. Straight line equal to we can draw. So the point is 0, 1, this first point. So this first point, and 1 comma 0. 1 comma 0 second point is here. Okay, so through this I can draw a straight line. So for this straight line, the first constraint is this straight, but less than or equal to comes here. So which is the area? The area towards the origin. Towards the origin, we have to give a shade, a blue color shade. Okay, right. So this first constraint over. First one is for equal to. We have got 2 points. We have draw the straight line. After it's less than or equal to, the area is towards the origin shade. I have given the blue shade, and we see that that is coming like this. Similarly, for the second constraints, 2 points we have to get. Suppose x1 is equal to 0, x2 equals 4. If x1 is equal to 0, what take place? X2 is equal to 4. That's what the first point. Suppose x2 is equal to 0. X2 is equal to 0, I have put here. If x2 equals 0, x1 would be 4 by 3. That's what the second point I have here. So with these 2 points, I can draw a straight line on the graph. This is what the straight line on the graph. Okay. First point is 0, 4. 0 on the x-axis, 4 on the y-axis. Second, 1.33 on the x-axis, 0 point on the y-axis. So we'll have here. So join these two, we'll get constraints 2. Now less than or equal to comes. So I told you that towards the origin we have to give the shading for less than or equal to. Suppose this is greater than or equal to comes, then above the against the origin we have to give the above area. Okay, here less than or equal to in the second constraint. So I have given the yellow color shading. Very good. Now we have to find the area of fusible conditions. Okay, so before that we have to take the measurement, everything. That's also very important. Some students are not writing this. This is very important. Now what is area of fusible solution? Area of fusible solution is the intersecting area of this constraints, and this fusible conditions. Okay, this constraints, as we have this and blue color area, this constraints is this straight line and yellow color area. These two kinds are two areas are the first quadrant. Am I correct? First quadrant, this area, first quadrant, this area. Now the intersecting area of this and this is this one. You look at that. Yeah, red color, a triangular like, right angle triangular like. Am I correct? Yes. Look at this. This point, and this point, where all these areas are intersecting area of first constraint, second constraint, and this fusible condition. So this is called area of fusible solution, meaning that all the points here will give us a solution. Solution means that will satisfy all these three conditions, two conditions, and this including fusible conditions also, that will satisfy. So we have to find the area of fusible solution. That's the next step. So after finding out this, all the points will satisfy this, this, and this, but all points here will not satisfy the objective function. That is, maximum for our objective function will not satisfy. But the expert, LPP expert, operation research expert, says that the maximum will be attained at the corner points of the AFS, this point or this point or this point. That's what the expertise says in that particular field. So we are substituting the value, this point value 0, 0, this point value 1, 0, this point value 0, 1, that is corner points of the AFS, in the objective function z equals 2x1 plus 3x2. So the objective function we are taking is z is equal to 2x1 plus 3x2. In this objective function, substitute this value 0, 0. That is, this is what objective function. At the particular point 0, 0, I am substituting. I will get z equals 2, 0 plus 3 into 0, 0. So the objective at this particular point is 0, objective function. Now let us take the other point, that is this point is 1, 0. Let me correct, on x-axis 1, y-axis 0. So substitute that in the objective function, same objective function, z equals z is 1, this 1 plus 3 into 0. You will get 2. You will get 2. Then the third point 0, 1, 0, 1, at this particular point the objective function gives z of 0 plus 3 into 1 equals 3. Okay, so 2 into 0 plus 3 into 1 gives us the answer as 3. Now, what is our aim? The object is maximize, not a minimize. It is a maximum. The x1, x2, which gives the maximum to this cost function, profit function, like we say that the solution, am I correct? Maximize. So x1, x2 should give maximum to z. So which value gives you maximum here? 0, 0 or 1, 0 or 0, 1. So 0, 1 gives the maximum 3 units for this objective function. Therefore that is a solution set. Therefore solution equals x1 equals 0, x2 equals 1, and the maximum is z equals 3. Okay, so this is the solution for this given linear programming problem. So this is the way we can do any problems. A quick look at what we have done. From the given constraints, we are finding out the straight line, then its area, including this, then intersecting area we are finding out. We will get the corner points. Expertise say that the corner points of the AFS, area of fusible solution, will give the maximum or minimum to the objective function. So our aim is to maximize it. Therefore, at the corner points of this particular area of fusible solution 0, 0, 1, 0, 0, 1, we substitute. Finally, we see that the value which gives the maximum, or the point which gives the maximum, is 0, 1. Therefore, the solution set is x1 equals 0, x2 equals 1. If we substitute these two values in the objective function, we get maximum z is equal to 3. So thus we can do the problems. Suppose the minimum they are asking there, then we have to find out the points where minimum we are getting. For this particular problem, the minimum solution is that this 0, 0, x1 equals 0, x2 equals 0, therefore maximum z equals 0. But here it's a maximization problem. Therefore x1 equals 0, x2 equals 1, and maximize z equals 3. So with that, I have to come to the end of this session. In the next session, we will see in another problem. Thank you.